The secret of the high voltage. Power generation of a stepping motor, Part 1. In this video, I will show you how to generate the DC 984 volts high voltage generator using a stepping motor in full step-by-step. The stepping motor is a special type of motor that can be controlled very precisely with high torque, so it can be used for robotics, automation, etc. Before we get started, I would like to ask you to do the following. My channel will enrich your knowledge, so I ask you to watch it from beginning to end. Thank you. This animation shows the most common form of a permanent magnet generator. The generator generates 1 Hz AC electricity when the center rotor rotates by 1. Therefore, the only way to increase the output of this generator under this condition is to increase the number of RPMs. This stepping motor was used to make this video. Other types are also possible. This stepping motor has 8 stator coils, and the rotator has 50 double serrated magnetic poles. However, the stator coil have 40 serrated teeth. This animation shows the movement of the stepping motor. It has 50 red serrated teeth and 50 green serrated teeth and 8 stator coils. Let's look at this video. And if you look at this, the 2 rows of teeth on the left and right are not in the same line with each other, so they can't meet the teeth of the stator at the same time. But one of the advantages of being a generator is that it can generate high voltages even at low rotations because of a lot of teeth. As shown in this figure, 1 rotation of the step motor on the left is the same as 200 rotation of the generator on the right. Now it's time to modify the stepping motor. I disconnected the coil and took out 16 terminals. I did this because the coil's winding shape is a mixture of some clockwise and some counterclockwise, so I disconnected all the terminals to avoid confusion. Then, 16 wires were connected to each coil to create 8 independent channels. Therefore, we can convert the generated electric power from each channel into DC through a rectifier and then collect it in one place. I finally put the lid back together. Now it's time to start assembling. This time, I've added rubber supports to the floor to absorb shock and vibration. The driving motor was installed and the flexible coupling was installed too. A fixture bracket for the stepping motor was made. Also, the tachometer and the rectifier circuit board supports were made. All right, all moving parts were installed now. I measured the resistance of all the coils. As a result, the resistance of all the coils were slightly different. This means that the output voltage of each coil will be different when it's generated. In this project, a tachometer was installed. Therefore, a magnet was attached on the flexible coupling outside. The tachometer and rectifier board support panels were made and painted yellow. In addition, 8 rectifiers were installed on the circuit board to convert the AC generated by the 8 stator coils into DC. The output voltage of all channels were different. The test readings were on the left side. The total output voltage is 907 volts. Amazing, 907 volts. This is the frequency of the output voltage before converting to DC. It shows 3207 Hz, extremely high. The rectifier and 16 electric wires were connected. The tachometer and output terminal are now installed. The tachometer's power will be provided from outside of the system. All right, now let's start the last voltage output test. The drive motor receives electricity from household power through variable voltage regulator and rectifiers. The output voltage reaches 500 volts fast. 984 volts is the maximum. So let's wait and see until we get that value. The stepping motor makes the high-tone noises. This phenomenon also happened on my other YouTube video. The current RPM is over 3,800. This is a very unusual phenomenon that does not occur in a typical generator where the RPM is no longer increasing and the output voltage is increasing. We're waiting for the maximum voltage, so let's wait a little longer. Wow! We got the maximum voltage DC 984.9 volts just now. Now we've achieved the goal of this project. I turn off the motor. So the voltage and RPM are decreasing. I'm going to operate the electrical device with the power output from the device in the next video part 2. Thank you for watching. Please click like and subscribe to my channel. I hope see you in next part 2.